any participants is having questions in theoretical part, now I'll be moving on to R. If anybody is having any questions, you can ask me in 1 or 2 minutes, then we'll move on to R. Yes, please. Anybody want to ask some question? Anyone? Nabanita Mukhopadhyay, any question from your side? Fatima, Chandra? Yes, please. Nabanita.
Hello, sir.
Yeah, please.
Asif. Class is here.
Sir, can you please say it about the intercept and slope again?
Intercept and slope. Okay.
Yes, sir.
Intercept and slope. Can you see this PPT? Is it visible?
Yes, sir, it is visible.
Okay. See, this is a scatter plot. You can see the dot lines are scatter plot when you plot X and Y. Then in scatter plot, we draw a line, and that line is called the line of best fit. Now, to draw a line, how many points you require? You require only 2 points to draw a line. Yes? Yes or no?
Yes,
Asif
sir.
Saab, you require only 2 points. From where these 2 points will come, as I mentioned, that you will be able to estimate B0 and B1 from the given data. Now you give one value to X, that is your first point, you will get one value of Y. So 1 point is known to you. You give another value to X, another value of Y will be known, so another point is known. And this line has been drawn, by taking the 2 points from the estimated equation, right? Now this line is basically called line of best fit, and it crosses through the maximum number of dot points. Wherever this line crosses this y-axis, this is a y-axis, then the distance from origin to the crossing, it is crossing up to this. So this distance, which I have marked, is called intercept. So it's a distance from origin to wherever it is crossing the y-axis. This intersection point, right up to origin, this distance is called intercept. What is the slope? You drop a line. Suppose I drop a line parallel to x-axis from here. Then some angle will be formed. Some angle. For example, I drop a line here. Some angle has been formed. Now, whatever the angle this has been formed, this is called slope. Slope can be written in terms of angle. Actually, there is a mathematical formula. So slope is nothing but angle. For example, this could be, say, 35 degree, or maybe it could be 55 degree angle, or it could be 90 degree angle. If it is 90 degree, this will be 90 degree. So it virtually determines the slope of the line, and this determines where it crosses the y-axis. So these are called intercept and slope of the line. For every line, there is an intercept, there is a slope. So these two things are important for a line. Is this clear?
Yes, sir. Yes, sir. Clearly understood.
Okay. All right. So I'm just, for the time being, closing this and coming back to now the practical part. See, whenever we work in R, I will suggest each and everyone that you make a folder on the desktop. For example, you can make a folder of your name. If your name is Asif, you can make a folder of Asif or Nabnita or whatever. Or, for example, this training I'm giving for Vishwa Bharati, so I have written the folder name as Vishwa Bharati. And you keep all the files, whatever you want to do, Excel file, even SPSS file if you want to import, or any other file related to program, you can keep all the files in that folder. What will be the advantage? Advantage will be you will not have to choose path again and again. I think this has been covered in basics of R, right? So we make a folder. So this is the folder I have made, Vishwa Bharati, and if you open this folder, you will see that this is just a history. History can be deleted. This is just a, so some files are there like age and sex file, ANOVA, and PMI file, cluster file, then some other files. So whatever the files I required, I have kept all these files here in this folder. So there is no need to refer or give the path again and again. That is the advantage of making this folder. So I have already written some programs because otherwise it's very difficult to type each and everything. So I have already written some programs, not even programs, they are simple tasks. and I'll just start from there, how to compute correlation and everything. So there, this is the file I have created, Vishwa Bharati, right? So I'll just open, this will open in RStudio. Hopefully you are aware of RStudio. So it will open, the file will open in RStudio. So this is the file you can see. Can you see this screen? Is this screen visible?
Yes, sir.
Yes,
Okay.
sir.
Now you see, because our first part was related to correlation and regression. So this is our workshop at Vishwa Bharati Shanti Niketan. So whenever I put a star, the hash means this line will not be treated to execute. This will be treated as a comment. So whenever you put hash means this line will not be executed by R. This will be treated as an just a comment. Now we are looking into correlation and regression. The first thing when you start doing operations in R is to get to your directory. Now, if I see which directory I am, so there is a command which is called get working directory. If I place get working directory and this close this bracket, and you can run this. So you are already into the directory of the Vishwa Bharati. You are already. But you can also, if you are not, let's say you are into directory of document or desktop or somewhere, then you can use this command which is called set working directory. Then use the path. From where I get this path actually, this C users air desktop Vishwa Bharati. From where I get this path, I will tell you. Hopefully this has already been covered. For example, in Vishwa Bharati, if you right click and come to the properties, and in properties you can see this path that you are here. C user desktop, and after that you can put one more slash and put the name of the folder. That is Vishwa Bharati. That is the path you can. So this is the path I have written, which is here. You can check that. So just opposite slash will work. The other slash, the backward slash doesn't work in R. You have to replace those backward slashes with forward slashes. And user air tab, up to this it was clear, and I just put Vishwa Bharati. So set working directory. So your working directory will be Vishwa Bharati. Run here, and then you can check whether you are into your own directory or not. So get a working directory. Now you are into, already we were in there, but if you are not, then you have to execute these commands. I will send you this file for practice, and you can later on practice also. Okay. Now, obviously, in order to compute correlation, I need at least two variables. So let me create one of the variable with these values. So this is one variable I have created, X. It could be height, it could be weight. I have just randomly taken few numbers. Then I have taken Y also. For each X, there is Y. For each X, there is Y. You remember, because correlation can be computed if the pair data is present. Pair data means you have Xi and Yi. They are present in pairs. Just like we have shoe pair, left and right pair, then and only then you can walk properly. Same thing is in correlation. We have one variable relating to one aspect, another variable relating to another aspect of the same individual. Say height and weight of the same individual, say age and blood pressure of the same individual, and so on. So I have taken one variable as X. How to create a vector? You start with C. C stands for concatenate. Then you enter some data with commas, then Y and another vector. So you have created two vectors here basically. So if you press X, if you press Y, and let me see what is X and Y. So if I press X, you will get the value of X. If you press Y, you will get the value of Y. So if you do this, you will see what is X. So this is your X, values in X, and this is your Y. So these are the values in Y. So you have
Yes.
created two vectors. Yes, please.
Sorry, sir, for the interruption. Sir, I have copied the path set with automatically bracket came, then I paste the data, the path.
Then reverse
in
the
error.
slashes. Reverse the slashes. You need to reverse the, and also put the double quotes. Double quotes is
quotes.
double quotes. Have you put the double quotes?
Yes.
And then reverse the slashes.
Reverse the slashes. Okay.
If you reverse the slashes, then and only then it will work. Otherwise, it will not work. Just do it.
error use without hex digits in character strings starting. C dot slash U.
Have you copied the path from there, going into the properties?
Yes, sir. I have copied the path.
Copy the path. Let me do it. Let me do it for you. I can show it in front of you.
Okay, sir.
Then it will be more clear. You see, this is the folder.
Yes, sir.
I just go to the properties and
Yes, copy.
just copy from here. All right.
Yes, sir. Copy.
This is copy. Close. Go here. And then let me put this set WD, and then this bracket will come and control V. So I have copied the path. Okay. Right.
Yes, sir.
And then you put a column here and reverse these slashes. Either you reverse the slashes or you can have one more slash here. It will also work. You can have the two slashes. This will also work. Doesn't matter. Either you reverse the slash or do it this. Then double slash. And then the name of the folder. Name of the folder was Vishwabharati. Just copying from here, Control C and Control V. And then put this. That's it. So there is no red sign now. And if you press this and run it, you will be at the get working directory. You will be into your own directory. Is that okay?
Yes, sir. Clear now.
No error now?
I am applying now, sir.
Just a minute. The error has been removed or not? The error has been removed?
Yes, sir.
Yeah, that's good. So I have created just two vectors. Let's say one vector is X, another vector is Y. And if you check X, these are the values in X. These are the values in Y. But the number of observations in X and number of observations in Y, they are same. Let me have a plot. Now, if you have a plot of X and Y, that will give you, can we apply Karl-Pearson correlation coefficient or not? So because Karl-Pearson correlation can be computed only when the points are along straight line, either they are increasing or they are decreasing. Let's say plot. So if you plot, you can see the points are like this. So points are increasing. Points are increasing. So you can expect a positive type of correlation between the variables. You can expect looking at this diagram. So when X is increasing, Y is also increasing. So you can expect a positive type of correlation and points are increasing. Of course, if you look at the slides, you will come to know that there is not a very strong relationship, but you can expect at least a moderate type of relationship between the two variables. Yes, please. Is this clear? Hello?
Yes.
Yeah. Now, how to compute the correlation between them? Correlation between them is given by this command. Simply write down, because we want to compute correlation between X and Y. So I have written COR. COR stands for correlation. Just write first three words. Correlation between X and Y. So if you do that, you can see the value. So this is the correlation, right? This, let me go through a little bit here. So this is the correlation. Correlation between X and Y is 0.742, 4835. So that is the amount of correlation between the two variables. Its sign is positive. That means there is a positive correlation. This is the value of R. R lies between -1 to +1. -1 to +1. Now, to check whether this is a Spearman's rank correlation. Sorry, this is a Karl-Pearson's correlation coefficient. Whenever we give this command, without specifying the method, that means we are getting correlation coefficient. We are getting correlation coefficient of Karl-Pearson. So by default, R will give you Karl-Pearson's correlation coefficient if you execute this command. You follow my point? COR X and Y. So it will automatically, by default, it will give you the Karl-Pearson's correlation coefficient or product movement correlation coefficient. I don't know whether this is significant or not, because p-value doesn't appear. When it will be significant? It will be significant. It will be significant only when p-value will appear. If p-value will be less than 0.05, then you will say that correlation is significant. If p-value is more than 0.05, p-value is non-significant. So what is our hypothesis, which I'll touch upon tomorrow, that in detail? Your H0 is that there is no correlation between X and Y. You can write down maybe H0 is there is no correlation between X and Y. Alternative H1, there is correlation between X and Y. There is correlation between X and Y. And if p-value will be significant, that means p-value will be less than 0.05, then you will reject the hypothesis. Reject which one? We always reject H0. So H0 says that there is no correlation. So if H0 is rejected, that means there is a correlation, right? Alternative will be automatically accepted. Then how to get the p-value? Just write core.test X and Y. So it will give you a p-value along with this correlation value. So run this and you will get, you can see, this is the p-value. P-value is 0.008 because correlation is tested by using a test statistics which is called T, which I'll discuss tomorrow in detail, right? And it will give you a T value corresponding to that. You will get a p-value. For the time being, please remember that we have to just look at the p-value. So your p-value is 0.008866. So this p-value is less than 0.05. If it is less than 0.05, correlation is significant. Correlation significant means X and Y, they are related to each other. And moreover, sign is positive. So complete interpretation will be that there is a positive correlation between X and Y and it is significant. There is a positive correlation between X and Y and it is significant. Yes, please. Interpretation is clear? Hello?
Yes, sir.
Anybody? Yeah.
Sir, interpretation is clear, sir. Sir, can you just move up, sir, in this script file, sir?
Yeah.
This X and Y variables, no, sir? There are numbers, no?
Yeah, they are values. They are values.
Are these extracted from the files that you have in this
No.
Mr. Bharati, or this has been typed manually, sir?
This have been typed manually, but you can extract also, which I'll take up the next example.
Okay,
Just wait.
thank you, sir.
I'll take up the next example where I'll extract it also. This
Thank
is a
you.
simple thing, so but anybody can understand that I have taken one variable x, another variable as y, plotted and show it to you that we can compute curl Pearson, because that is the main thing. If there would have been curvilinear type of relationship, I would not have computed curl Pearson correlation coefficient. If you look at the slides, hopefully everything should be clear to you, right? So plot and x and y. Yes, please.
Sir, please explain the interpretation of p-value once more, please, sir.
Okay. If you are carrying a pen or pencil, please write down H0. What we are testing here. Your H0 is, H0 means null hypothesis. Your H0 is, there is no correlation between X and Y. There is no correlation between X and Y. This is our null hypothesis. What is an alternative hypothesis? For every null hypothesis, there is alternative. Alternative hypothesis will be just opposite of this, that there is correlation between X and Y, or you can say X and Y are correlated. Even under H0, you can write X and Y are uncorrelated. Alternative will be X and Y are correlated. So correlation, once we compute correlation, then there is a test statistics which is called T. And based on that T, p-value will be computed. Your aim is to just look at p-value. If your p-value, you can note down please, in statistics, if p-value is less than 0.05, if p-value is less than 0.05, then you always reject H0. Let me just repeat. If p-value is less than 0.05, reject H0. What was our H0? That there is X and Y are uncorrelated, but it has been rejected. What is alternative? That X and Y are correlated. So I'll say that yes, based on the p-value, because it was less than 0.05, I'll reject H0, and the interpretation is that X and Y are positively correlated, and there is a significant amount of correlation between the two variables. Yes, please. Interpretation is clear?
Yes, sir.
Okay. All right. Now suppose rather than using curl Pearson correlation coefficient, right? Rather than using curl Pearson correlation coefficient, let me have the Spearman's rank correlation coefficient. So for Spearman's rank correlation coefficient, let me just copy from here these two, copy, and paste it here, Control V. And let's say there are 10 people and they have been ranked. First person, there are two judges. So X is the ranks given in X, they are assigned by judge 1. Ranks given in Y, they have been assigned by judge 2. Let's say first person when comes to the stage, he has given this rank as 9. That means this person comes at 9th number place. This comes at 3rd number place. This comes at 1st number place. So 1, this comes at 5 number place. This comes at, let's say, a 2nd number place, then 6th number place. Then let's say 7th number here. And then we have 8, 9, 10. So let's say this comes at 10 and this comes at 8. Right, which one is left? 1, 2, 3,
4.
4 1 is 4 is left. Anything else? Okay. Right. 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay. All right. Let's say Y I take that these are the positions which have been the first. Which one has comes at number 1? That means the third contestant has been at the top. And which one is the last? This one is at the last. If some names are given, you can identify which one is at number 1, which one is at number last. But the second judge may have different opinion. He can write this as 5, this as 2, this as maybe 10, this as let's say 6, this as say 4, this as 3, this as 9, this as 7, this as which one left? 4, and this one has 8. I think everything is covered. Okay.
4 is double, sir.
4 is double. So which one left? Which one is left? Right.
One is left.
This one. Is it okay now? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Is that okay? So these are the ranks given by X. These are the ranks given by Y. So my data is now X. This is Y. Now I want to see whether these two judges, they have some kind of agreement or not. That is a question. If there would be some agreement, correlation will be high. But since the data is in the form of ranks, so I'll not compute Karl Pearson. I'll compute Spearman's rank correlation. Do you agree with me? Yes?
Sir.
Yeah. So I need to write covariance or correlation between X and Y. Method will be Spearman. Only you are changing the method. If you don't write any method, it will compute Karl Pearson correlation coefficient. But if you specify the method, it will compute Spearman's rank correlation coefficient. So correlation is coming out to be very close to 0, very poor type of correlation. And if I want to check whether the p-value is non-significant or not, so you can check. So this is the p-value. This is the p-value which is 0.86. Now p-value is more than 0.05. If p-value is more than 0.05, what does this mean? If p-value is more than 0.05, then H0 will be accepted. What was H0? H0 was that there is no correlation between X and Y. So my final conclusion will be that the judges definitely differ in their opinions because there is no correlation. Are you following my question and answer? Yes, please.
Yes, sir.
Yeah. Anything? So this is about Karl Pearson's correlation coefficient, Spearman's rank correlation coefficient. Very simple to compute in R. Now I'll move on to simple regression also. How to move on to simple regression? There will be X values, there will be Y values, right? I'll move on to simple regression also. So in simple regression, one of the variable will be dependent variable, another will be independent variable. So this is a simple regression analysis. This was the simple correlation, Karl Pearson and Spearman. So click on to X and Y. They are the same X and Y. Now, how to write down a linear model? Because the condition for Karl Pearson correlation coefficient or the linear model is that correlation between y and x, they should be linearly related, or y and x, they should be linearly related. So we use the term LM. LM stands for linear model. Linear means points are along a straight line. Model means you are fitting the linear model. So LM stands for linear model. And then linear model, how to specify, very important. I'm just writing model here. I'm specifying LM. LM means linear model. Then substituting this bracket here. This bracket says that dependent variable you take at the first. Y is a dependent variable. Then put a curl on each and every desktop. You have a curl sign. Do you know the curl sign? On every desktop you have a curl sign. Yes, please. Hello.
Yes, sir.
Yes,
Yeah.
sir.
Yes,
Yeah.
sir. Yes.
So after the curl, you put your independent variable. So y is a dependent variable, x is an independent variable, and you are fitting a linear model. Linear model with y as a dependent variable, x as an independent variable. Are you following this point or not? Is that okay? Anybody can respond. Please, one person,
Yes.
please. One person
Yes.
whose mic is working well, they can answer my question so that I can understand that you are working with me. So, or you can just, I'll send you the file. You can work on the same file later on. So model means model will be run and the results will be stored in this file, stored in this vector, and stored in this variable that is called a model. Then I can look at the summary of this. What is the summary of this model, right? So for example, I run this. So it has successfully run. Now no result has appeared, but result will appear when I look at summary of the model. When I look at summary of the model. Okay. Now, if you press simply the model, then again it will give you the result. But better to give you the summary model so that you can get at a glance many other results which are required. So if you press this summary model, you will getting the complete information. You see, it says that this function has been called by R. Your minimum value of the residual is nothing but the difference between the predicted value and the actual value. So minimum residual is this much. This is the first quartile, third quartile, median value, maximum value of the residual. But nothing to worry about this residuals. You just look at what is the final equation. So this has been from the given data. Data was there, and from given data, beta naught, if you remember, and beta 1, they have been estimated. Beta naught and beta 1 have been estimated. What is the value of beta? What is the value of beta naught? 29.9165, because it says estimate. Estimate of the intercept. What was intercept? Beta naught. So this is the estimated value, 29.9165. And the coefficient of x, coefficient of was your beta 1, if you remember. And the estimate of beta 1 is, these are coefficients, coefficient of intercept, coefficient of x, right? Coefficient of x means beta 1. This is the estimated value of beta 1. So what is your final equation actually? So if you want to write down the equation, your equation will look like this, that y is equal to intercept. Intercept means 29.9165 plus beta 1. Beta 1 is 0.7987 multiply by x. So this is your final model. Y can be estimated from this equation. Now you give any value to x, you can estimate y. From this equation, I'm just writing down. Yes, please. Is this clear? Hello? Hello?
Yes, sir.
Yes,
Yes,
sir.
sir.
या अभी सेकंड नंबर पे किसने बात किया था, जिसने
Yes,
दोबारा
sir.
बोलिए आप. या आप अपना माइक थोड़ा ऑन रखिए प्लीज, क्योंकि आपका ना डिस्टरबेंस नहीं है पीछे बिल्कुल भी. बाकी को थोड़ा
Okay.
म्यूट कर दीजिए आप. मेरी इफ यू अंडरस्टैंड, I mean, you just asking some question, you can answer. Is that okay how I have written
Yes,
this
sir.
equation? Yeah, okay. So just the constant, this is the value of beta naught, this is the value of beta 1. If let's say this would have been negative, I put have negative sign then, because this is negative. That means there is a negative relationship between y and x. Since it was positive, so I have written positive. So this is that estimated equation. Okay, this is that estimated equation. Now, one more important point, because these are called coefficients. This is the coefficient for intercept. This is the coefficient of X. If I want to see the confidence intervals, of the model, let me just explain you what we have got in. This is called the standard error, then t value and the p value. Now for intercept, the p value is non-significant, but we will not have to bother about the p value for intercept. What is more important, that p value for regression coefficient of X must come out to be significant for a model validation purpose. Your model will be valid only, please listen to me carefully, your model will be valid only if p value related to the coefficient of X will come out to be significant. And significant is always marked with star or double star. Star stands for significant, double star stands for highly significant. So here you can see the coefficient of X and it is significant. P value is less than, this is a p value, actually this is p value 0.008, which is less than 0.05. So p value is significant. That means you can predict Y based on X. You can predict Y based on X. But suppose this would have been non-significant. Then prediction of Y is not possible from X. Prediction of Y is not possible from X. You stop this model. This model will not work. You follow my point?
Can you please come again, sir?
Yeah. I am saying that
Last part, sir.
yeah, confidence, you see what I'm saying, that significance of the regression component is very, very important, because our model is, if you remember the model, our model was Y is equal to, let's say B1 plus B2. Let me put this as B naught in the same notation. B naught plus B1 multiply with X. This was the model. So here your B naught value is 29 point this, your B1 is 0.79 this into X. Now, suppose this coefficient is non-significant. Let's say this coefficient is non-significant. If this is non-significant, what does this mean? Let's say this coefficient value is 0. Let's say beta B1 is 0. When B1 will be 0, then 0 multiply X will be 0.
Yes, sir.
And your Y will be Y will be simply a constant. That means you cannot estimate Y from this X, because there is no role of X once B1 is 0. Yes or no?
Exactly,
Yes, sir.
sir.
You follow my point? Now, what is actually this test? It is testing. This is what is this test? This t-test is testing the H0. You can write down the H0, that beta 1 is equal to 0. Beta 1 is equal to 0. That is your H0. Alternative, that beta 1 is not equal to 0. Now, if beta 1 is 0, that means you cannot predict Y from X, because X will go to 0. That means I need to reject H0. I need to reject H0. And when H0 will be rejected? When this coefficient will be significant. You can see this is coming out to be significant. P value is less than 0.05. If this would have been non-significant, that means your beta 1 is 0. You cannot predict Y from X. That's clear. But it says,
Yes, sir. So
but it
in
says,
this,
Mhm.
so in this, if intercept is also significant, and what would be
intercept does not make any difference for significance or not. Why? Because let's say this is non-significant. That means it is close to the origin. It's close to crossing through the origin. That's it. Nothing else.
Okay, sir.
Once this becomes non-significant, that means it is close to the origin. It is not very far away from the origin. This is what it means. So interpretation of the intercept you will not have to see. Only thing is Y depends upon X. It doesn't depend upon intercept actually. Is it clear? Intercept is given by the data.
Independent variable.
Yeah, X is an independent variable. So once the contribution of X is beta 1 is 0, that means you cannot predict Y from X. Is this clear? So this
Sir.
must be significant. So when star appears, that means this is significant. If there would have been no star, this p-value would have been more than 0.05, and that means this model is not applicable. Your X cannot predict Y. Is that clear?
Sir.
Yes, sir.
Yeah. Okay. Anything else?
Sir, I have one
Now,
question.
sometimes,
Sir, I
yeah,
have one
please.
question. If the model is insignificant, it means that there is no correlation. Is it so?
I'm not looking at the correlation now. I'm looking at the regression. Regression means how to predict value of one variable, that is Y, based on the other variable. Obviously,
Okay.
obviously, if correlation will be very low,
Yes, sir.
if correlation will be low, then this coefficient definitely will come out to be non-significant. So correlation form a part of prediction in regression. Whatever you are saying may be correct, that correlation was high. That's why this value is coming out to be significant. If correlation would have been low between Y and X, that means if there is no correlation between Y and X, obviously you cannot predict Y from X. That's clear. So correlation form a part of prediction. But simply looking at the correlation, you cannot predict anything. You follow my point?
Yes, sir. Thank you, sir.
Okay. Yeah. Then sometimes we also look at the confidence intervals. Now, what do you mean by confidence intervals? Confidence interval means you have taken some data and given the result that we can predict Y based on X because the result was significant. Okay. Now, somebody can take another data and give the result that this is coming out to be non-significant. I cannot predict Y based on X. Right? So confidence intervals are required in the sense that if 100 such data sets are taken, that you must be something clear. For example, here your estimate for beta coefficient is 0.7987. If you take 100 such samples from the same population, can I say that this coefficient will lie somewhere between this to this? Let's say, what is the meaning of confidence intervals? Exact meaning of confidence interval is, suppose I have to start class at 12 o'clock. Okay. Now, when I enter the class, some students are sitting already at 11:50, right? And let's say out of the class of 30, 7 or 8 students, when I enter the class at 11:50, they are sitting there. Okay. Now my class is at 12 o'clock. Up to 12 o'clock, let's say 5-6 more students have come. But if I give some flex, if I take the attendance, so out of 30, maybe 40-50% are there at 12 o'clock. Maybe sometimes even not that. Sometimes 10 students are present exactly at that time, right? But if I give little bit of flexibility, I allow that you can come up to 10 minutes or so. So by 12:15, you can expect that about 95% of the students will be present in the class. You agree with me? Yes or no? Hello?
Yes, sir.
Right? But if I take attendance exactly at 12 o'clock, maybe I'll get attendance present only for 10 or 12 students. But if I give little bit of flexibility, let's say up to 10, 12:10 or 12:15, I can expect that most of the students will be present. Okay. But smaller so my confidence interval is from 11:50 to 12:15. That's the confidence interval. So I can say that during this interval, I'm expecting that 95% of the students are likely to be present in the class. This is what do you mean by confidence intervals. Now, let's say smaller is the confidence interval, better is the result. Suppose all the students are present exactly at 12 o'clock, and there is 12 o'clock is my exact time point. Then I'll say that this is a very good class. Let's say my confidence interval is only for 7 minutes. I am coming 2 minutes early, and waiting up to 5 minutes, all of them are present. Up to 12:05, all of them are present. So smaller the confidence interval, better is the result. Larger the confidence interval, let's say 3 students are coming at, my class is from 12 to 1, and 3 or 4 students are coming at 12:50. How much they learn? They will sit in the class only for 10 minutes. What will be their learning? Nothing. So you will they will lose the entire information because it's a larger confidence interval. So larger the confidence interval, worse is the result. Smaller the confidence interval, better is the result. Is the meaning of confidence interval is clear? Yes, please.
Very nice examples.
Okay. All right. So generally we compute confidence intervals, confidence interval for intercept and for and this. So these are the confidence intervals. It says the confidence interval for intercept is from this to this, and confidence interval, you see, intercept is not important, but this was the one based on one sample. But if you take 100 such samples, that this coefficient, this estimate will lie between these 2 points, 0.25 to right up to 1.34. In 95% of the chances that this this regression coefficient will lie between these 2 points, even if you take 100 such samples. That is the meaning of confidence intervals. Okay. Now, plot x and y again. You are getting this picture. And this picture you can see from here. That is a plot of x and y. And AB line, A stands for intercept, B stands for slope. AB line means it will plot slope and intercept of the model. So if you do this, you will see the exact line. This is the line of best fit, which I was showing in my PPT. So this is the line of best fit, and this is the scatter plot. Now, for this point, which is almost exactly on the line, the error will be very less. For these 2 points also, error will be small, but for this point, error is likely to be more. So if it is points are moving away from the line, error is likely to be larger, right? And I want to fit the values. See, now there are actual values which are available to me. They are given in the data. And one will be based on, see, y is equal to a plus bx, or b naught plus b1x. So b naught and b1, they are known to me. I am giving different values to x to estimate y. So there are actual values of y and there are predicted values of y. So this line is based on predicted values. This line is the actual value. The difference between the two will be the residuals. So this R also give you different attributes of the models. These are the different, you can look at the coefficients, you can look at the residuals, you can look at the rank of the matrix if you are interested into mathematics and all that. For example, model coefficients. These are the model coefficients. This was intercept. This was the slope coefficient. Model fitted values. So these are the fitted values. These are the values which are given by the model. Actual values are already there. And if you see the residual, these are the residuals. That means the difference between the actual value and the predicted value. Yes, please. Is this clear? Simple regression is clear? Hello?
Sir, this confidence intervals, as we can see for this x, the independent variable, it is the range is less, and less the range is better the result.
Better the result. Yes.
But what is the ideal range, sir? Can we
No, there is no ideal range. Only thing is we can look at the closeness, how close they are. I mean, you can drop a line. Let's say I drop a line from 0.25 to right up to 1.34, right? And the actual value from the data is 0.79. So if this 0.79 is the closer this value to the 0.79, the better will be result. If they are moving away from 0.79, let's say this would have been minus 0.27 to right up to 34.36, right? That means you are moving away from this line. There is no idea of going for such type of model. And in that case, it may come out to be non-significant also. So that was the question actually. Now, this is not very far away. It's a 0.7 into 2, so it will give you about 1.4. So it's closer to that. So seems to be okay, right? You follow my point?
Yes, sir.
Okay. Now we look at another example of the simple linear regression. I have the age data. I have the blood pressure of each. This is age and this is blood pressure of the patients. Right? 1, 2, 3, 4, 5. 6 patients are there with age and blood pressure. I just put the data and blood pressure and age. I want to estimate the blood pressure based on age. That is a problem. So look at the plot, and plot is given in some nice form with the title For example, main title is age versus blood pressure, subtitle is age in years. Then you have the Y limit, that blood pressure lies between 100 to 180. Then you have the main column as red, column this as sub column as blue. So you will get a very nice picture. So if you plot this, you will get this thing. Age versus blood pressure, age in years, age. So age is plotted this and this. Then you look at the correlation between age and blood pressure. Just run this. So this is a very high correlation between, and you want to see that it will come out to be significant. Obviously, because high correlation, you can check that. So this is the p-value, 0.003. The smaller the p-value, better is the result. Smaller the p-value, better is the result, because it will give you that correlation is significant. And again, fit the model. Earlier I have written fit model, now I am writing fit. You can write anything. You can write your name also. So everything will get stored into this fit. Linear model, we want to estimate blood pressure based on age. So again, run the same thing. Summary fit, again the same type of, and abline fit, you can look at this plot. So very close line, right? Better fit because correlation was high. So better fitting of the model. Okay, now this is all about simple correlation and simple regression. Before moving on to multiple correlation and multiple regression, let me give you some idea about how to plot. Let's say there are two sets of variables. One, let me look like this. Just try to understand what I'm saying. Let's say there is a male data and there is a female data. Okay, there is a male data, there is a female data, and let me change this data. I'm writing this as male, writing this as male, and then same type of variable have been studied for female, and now I need to change all this. This is male, this is male, this was female, and this is also female. I'll explain you, just wait for a moment what I'm trying to do. So also female. Then, okay, rest of the things are okay, that they can work. Okay. Now here is, there are two sets of variables. One is x1, another is y1. Let's say x1, you can think of that it is some score related to, say, out of 10, the scores are given for physics, and y1 scores are of mathematics, and scores are available for male. There are in the class, there are male and female. So I have put down these scores for male of physics, scores for male of mathematics. Then creating a second variable for female x2 and y2. That means they are referring to female for scores of physics and scores of mathematics out of 10. Is the data clear? Yes, please. Hello.
Yes, sir.
Now,
Sir.
question is, yes, please. You want to ask something?
No, sir.
Okay. Now, question is that if I want to have a scatter plot, of male and female, then I should have different dots for male and different dots for female. Yes or no? So that I can see that these are the dots for male, these are the dots for female. You follow my point?
Absolutely, sir.
Right? So here I can write this as, let's say, instead of variable this, I write this as male. I write this as female. I'll show you that what is happening. Okay, just remove this too. All right. Now, then you can see a scatter plot of dots. Just plotting this, taking y, x is taken into consideration, y is also taken into, then female data is also taken, female data for the second variable is also. Now creating a scatter plot of actually male and female. So it will execute this command. So run this, And now you are getting, because we have given the color as dark blue. So you can see the dark blue dots. Can you see the dark blue dots? Yes, please.
Sir.
Yeah.
Yes.
So these dark blue dots are for, because we have taken the male data. Is that okay? Hello.
Okay, sir.
Let's say in the same graph, let me add female points also, so that I can distinguish that these dots are for male and these dots are for female. So adding scatter plots for female. So if you do that, and if you enter, so you can see these, I have given the color for red. So these, you can see the red colors. So you can distinguish between male and female. Is that clear? The graph is clear? Hello?
Yes, sir.
Sir,
Then
it's
I
clear.
can, yeah. Then I can, similarly, you can take the third variable and give this command, points. Let's say third variable is for the third gender, and give x3, y3. So you will get the third dot also. Sometimes these pictures are very, very useful. Hopefully you see what because these are relating to actually correlation. Can I see some type of correlation between male and female? Yes, if you see that males are also increasing, females are also increasing, you can have a similar type of pattern, more or less, right? Nothing much. But let's say all blue dots are here, all red dots are here. So that means they are behaving differently. There is one cluster for male, another cluster for female. But here is a little bit of mix up. You follow my point? Hello?
Sir. Yes.
So you can also look at the legends. Legends I can define. Let's say I want to define that red, dark blue color is for female, and for male the color is red, right? So you can use 1 and 9 means that at this point it will take 1, and at this point it will take 9, and the legends will be displayed here. So legends will be that male and female, and this is called plotting character. I have given some plotting character and some color, and if you run this command, you will see some nice picture. You see that this is for male and this is for female. So this is how you can draw a nice graph. I mean, I'll send you this file, then you can practice this. And if you want that this should appear somewhere here, then you can change the place. You can write this as 8 and this as maybe same 9. So this box will appear here. Where if you want this box to be here, you can write this as 9 and this as 1. So box will appear here. So wherever you want, you can place this legend. Is this clear? Hello?
Sir.
Yeah.
Yes, sir.
Now somebody has asked me this question, that these are the data sets I have taken. These are the data sets which I have taken. Now if I want to take some file from some file, so there is one file which is called empty cars, and it is on my, this empty cars is also available in the sample files of R. You can extract from there, and you can have this file in even in your folder. So let me take the data from this, attach empty cars. So let me see what is there. View empty car will give you this capital view. We will give you the data, that what kind of data is there in empty cars. Let's see which kind of data is there. So it will display here. It is related to different kind of cars which are there. You can see the name of the car. For example, Mazda. Then some different names, Duster, Merc, and all these cars are here. Honda, Civic, Toyota, Corona, all these cars are here, and they have miles, cylinder, which 6-cylinder, 4-cylinder, 2-cylinder. Then this is a displacement of something, horsepower, then some other variables. Can you see the data of empty cars?
Yes, sir. In which
Yes, sir.
type, sir, you have saved this file in your folder, sir? Is it an Excel file?
You can either save in Excel file, or this data is available in R samples. Tomorrow I will show you how to extract R. There are many files in R samples, right? My sample files are available in R. They are inbuilt, and this file I have taken from them. How to take out a sample from the R files, I will show it to you tomorrow. Please remind me this thing. Okay, tomorrow.
Yes, sir. Just
Otherwise, there will be a little bit of deviation right now from my
one
main thing.
small query only, sir. This is in format which is compatible to us. In most of the
Yes.
times, we have it. We have our
Excel
data
file.
in Excel.
Yeah.
So if you can touch upon that also, sir, it'll be
Yeah,
very.
yeah,
This is
I'll-
exactly
I
what I
can-
want to learn.
After this, I'll just touch upon that. Don't worry.
Thank you, sir.
Okay. So this is some variables are here, right? Some variables are here, and which includes mileage per gallon. I think this is mileage per gallon. This is cylinder. This is some displacement, horsepower, some draft, weight of the something, and this and this. So many variables are here, and this is the all information related to the cars. Now you can just click here. It will go out of the picture, and you will be here. Now let's plot. Simply, we plot weight versus miles per gallon. If weight will be high, weight will be, obviously, if the weight of the car is more, you will be having less mileage. If weight will be less, you will be having more mileage. Light vehicles always give you a greater mileage, right? So that's why we are doing something. So I plot this, and you will see the graph. So this is scatter plot of weight versus miles. Scatter plot of weight. The main title I have given scatter plot. X label I have given weight. Y label I have given miles, and something others are just colors and other things. Now let's add fit line to this. If you add fit line, again, mileage will depend upon weight. If weight will be less, mileage will be less. So mileage will be more, and if weight will be more, mileage will be less. So fit the model and summary of the model. So you are getting the same picture. I'll not explain again and again. It's just taking variables from some file. That's it. So plot the ebb line and all this, and you will see a picture that this is the fitted line. If you fit a line, it will look like this. So this is the fitted line. So it's a decreasing, and correlation must come out to be negative, and you can see a negative correlation between the two variables. How
So
to
what
check
is the command to fit the line?
Command to fit the line is this one. AB line model. Model is here. AB line model, and you can give any color. If I change this color to, let's say, blue to, say, black, it will give you black color. On this, you can have a black color rather than blue. So you can change this color. AB line means A stands for intercept, B stands for slope. AB line of the model which we have fitted. Is that clear? Hello?
Yes, sir.
Yeah. So you can see a very good amount of correlation, but can you think of that correlation is negative or positive? Yes, please.
Negative, sir.
Negative. And that is likely to be, we are expecting that also. Because if weight of the car will increase, mileage has to go down. Yes or no?
Yeah.
Yeah. Trucks give very low mileage. Cars give high mileage, particularly Maruti and these give high mileage. But the cars like Innova or something, they are giving less mileage because they are heavier. All right. So we want, you can check the correlation also. Let's say correlation and testing also, correlation test. Let's say between these two variables, weight, one is weight, comma, MPG. And if you check this correlation, it should come out to be negative. It's come negative, you can see. Minus 0.87. Is that clear? Hello?
Sure.
Yeah. Okay. Now, I have shown you that if there are data sets, then you can have different scatter plots. Now, sometimes in our data set, we were having weight, we were having MPG, mileage per gallon, then some displacement and the type of the cylinder. Let's say I want to see in pairs what kind of scatter plot. You can, in scatter plot, you can have two variables only. But let's say I want to have a scatter plot of 6 variables at the same time. All 6 variables, one is related to another, one is related to the third one, one is related to the fourth one, one is related to the sixth one. Then these are called pair plots. And this is also covered under scatter plot matrix, right? So this command is used. I have used these variables, weight, miles per gallon, display, and 4 variables. So you will get a 4 by 4 matrix actually. of the scatter plots, and data will be empty cars. Main heading will be scatter plot matrix. Let's do this, and you are getting this plot. So how to read this plot? It's very simple, because it will give you overall picture. For example, let's look at this one. This is basically a plot of weight versus the variable here. Weight versus here is MPG. This graph is weight versus displacement. This graph is weight versus cylinder. Similarly, other graphs. This graph and this graphs will be same, because this is weight versus MPG and this is MPG versus weight. Is that clear? Yes, please. Is the output clear? Hello?
Yes, sir.
Yeah, output should be clear actually from here. So this is how to draw a multiple scatter plots in R. Multiple scatter plots in R. If there are, we have taken 4 variables. If you would have taken 10 variables, you will get a 10 by 10 matrix. This is a 4 by 4 matrix. 1, 2, 3, 4, 1, 2, 3, 4. So if you would have 10 variables, you can get a clear picture of that. Okay. So this is sometimes useful, such type of graph, while denoting the correlation or a scatter plot. All right. So this is all about simple regression, simple correlation. Now we will move on to multiple correlation, and that will be the last thing for today. And if time will permit, maybe 15 minutes, I'll be able to cover this multiple regression. What is a multiple regression? Multiple regression is an extension of simple regression. Okay. Now somebody was asking me how to import a file. Who was asking how to import a Excel file? Hello. अभी आपने किसी ने बात किया था मेरे से कि you can. Hello. Are you with me?
Yes, sir.
Anybody? आपने किसी ने पूछा था ना मेरे से क्वेश्चन कि हाउ टू इंपोर्ट एक्सेल फाइल.
मैंने सर.
हाँ, आप देखिए कैसे इंपोर्ट करनी है. Just listen to me. I'll just show you which file is there. Let me see. This file is basically multiple.csv. Okay. So in the folder, you see, this is the folder. There is one file with the name of multiple. So this is a file actually. This file is multiple file, multiple dots. Multiple means multiple correlation actually. This stands for multiple correlation. So this is CSV. As you are saying that we can always save an Excel file as CSV file. You can do that. Okay. You know how to do that, right?
Yes, sir. While saving, sir, we'll have to.
Yeah.
do.
So while saving, you can do that. So I have already done this as a CSV file. So you can see this is a comma separated value. Can you see the heading over there? Comma separated value.
Yes, sir.
Yeah. Just
Suppose
open.
first you have converted Excel file to comma separated.
Yeah. Because
CSV.
Because it's easier to read the CSV file in R. You know that, right?
Okay. Yes.
Now press this. Let me show you. So it has certain variables. One of the variable is IQ. Another is mental age, then anxiety, then depression score, stress, communication score, and convolution score. It's a problem of the people from psychology. What is their problem? Problem is they want to estimate IQ. They want to estimate IQ of a person based on mental age, anxiety, depression, stress, communication score, and convolution score. So that means this is your dependent variable. IQ is a dependent variable. And how many independent variables are there? Can you tell me how many independent variables are there?
6.
6. So this is your X1, this is your X2, X3, X4, X5, X6. So you have 6 independent variables and 1 dependent variable, right? So it's a problem of simple regression or multiple regression?
Multiple, sir.
Multiple regression, right? Now you are with me. Now we will import. This file is already in my folder. This file is already in my folder and it is here. There is no need to give any path now because you are already into your own directory. Otherwise, you would have given the path. You follow my point?
Yes, sir.
Yeah. Okay. So I'm just closing from here. I have shown you the file and we will import this file. How we can import the file? Let me take this file as data. I'll store this file as a data. Read.csv. Read.csv. Now I am already into my folder. So even if I don't, I have specified the path for your convenience only. But if I do not specify this path, even this will work. There is no problem at all, because your file is already with you. Even if you give this, there is no need to give the path, because you are already set in your own directory. You follow my point?
Yes, sir.
Right? So how to extract this? Data, read.csv. Always write read.csv and the file name under quotes. Just run. It has been run. And where it has been stored, data has been stored in this file. Data. If you click onto data, you can see all the variables. You see IQ, mental age, anxiety, depression score, stress, communication score, convolution score. And if you press this command, which is called head, then you will get the first 6 rows, so that you can go through, because sometimes files are very lengthy. They are having 200 records. So I just want to see the top line and 5, 6, that how the data looks like. So you can give this command, which is called head. I think you are aware of, right?
Yes, sir.
Right. And if you use this command, see, there are 2 ways to extract the variables. This file has been extracted as a data frame. This file has been extracted as a data frame. And these are the variables here. IQ, mental age, 7 variables are here. Now,
Yes.
if I want to perform, let's say, analysis only on IQ, I cannot do. Because it's in the data frame. I need to take a separate out this. So one way is to separate out, that you separate out each and everything. How we separate each and everything? Let's say this is the way. I put IQ, then IQ has to be separated, IQ, and then $, and give the file name. File name is data. So IQ will get separated from this data. I think you know this thing or not?
Sir, we've been taught this, but somehow I was not able to comprehend. This is what I'm following you now, sir.
Okay. So if I want to extract any variable, so I have to do this every time. For example, second variable is mental age. So I'll write mental age, then again mental age, mental _a and data with $. Then it will extract one by one variable, right? It will extract one by one variable here. Okay, you follow my point?
Yes, sir. Extracting that variables itself is not sufficient for performing any analysis, no, sir?
You see, if in the data frame means you have a collection of different variables. Individual information about the data is not available to you. Let's say somebody give me this task that you have to find out the mean IQ, right? You follow my point? Mean IQ. Now IQ is in the data frame. Even if I give the command mean IQ, it will not give you the answer, because that is along with the other variables. Yes,
sir. Yes,
I
sir.
need to extract this. So what is the method of extraction? This is the method of extraction. That from this file you extract IQ. Now IQ will be extracted. Let me show you. IQ is extracted. Suppose I give IQ and I do this, run. I think there is I have written something wrong. Object IQ not found. What happens? Same variable. What is this? IQ $data. There. Why it is giving the error? I don't know.
Can we try another variable, sir?
Oh, I have written wrong actually. It should be data IQ, not IQ data. So data $IQ. I was using the wrong command. Now it's coming out. Is that okay? Now IQ has been extracted and now you can see the values of IQ. Otherwise, from the data frame, if you give let's say here, if I would have used IQ here, you will get nothing, because in data frame, all the variables are together, not individual values are available. You follow my point?
I understand now, sir. This has to be
okay.
followed for all the other variables.
All the other variables. But let me give you the simpler way. What is the simpler way of doing this? The simpler way of doing this in R, you use this command which is called attach data. If you use attach data, then automatically all the variable will give you individual information. You follow
Okay,
my
sir.
point?
Then we can, yes, sir. Then we
You can use
perform.
that.
Yes.
Then you can perform. So head data is this, and if you use attach data, now it says that they have been all have been masked, unmasked actually. Right? Now
Right, sir.
Now I'm just using this model. It's a multiple regression model. So model 2, again linear model, dependent variable here, then this curl, and write down all the other variables, independent variables with plus sign. The one of the variable was, see, when you use the, always copy from here so that you should not make any mistake. You always copy from here and put that here, so that if you write manually, there may be, you may miss some spelling or maybe some underscore. Put that, and then in between you write plus plus plus. You follow my point?
Absolutely, sir.
Yeah. Then our data is coming from data, because data is in data. So I have to specify from where to take data. So linear model, IQ. So it is just a Y. So the first coefficient is beta naught plus beta 1 x1 plus beta 2 x2 plus right up to beta 6 x6. Okay. Now I'll run this model. It's a multiple regression model. And in multiple regression model, you will get the value of R square also. So I run the same type. So model has been run. And if you see the model 2, now you see this is model 2. That this function has been called. These are all, this is the value of intercept. Rather than looking at this, you always look at the summary. This is always confusing. These are coefficients for each variable actually. These are coefficients of each variable. But to get it in the tabular form, you always look at the summary. So if you see the tabular form, now it's in the tabular form. This is the value of the intercept.
Beautiful.
Yeah. This is the value of the intercept. This is the value of the first coefficient, mental age, anxiety, depression score, stress, communication score, convolution score. Now, important point which I want to make is this one. Please listen to me carefully. I have taken 6 predictors. I have taken 6 independent variables or predictors. There was one dependent variable, that was IQ, right? I want to predict IQ based on these 6 predictors. Now, do you think all the predictors are important? May not be. Yes or no?
Yes, sir.
So I will include only those predictors who are making a significant contribution to predict IQ. Yes or no?
Absolutely, sir.
So now if you see their p-values, look at the p, forget about p-value of the intercept. Intercept, we are never interested. Whether it is significant, whether it is non-significant, it doesn't matter. But look at the coefficient of mental age. Coefficient of mental age is marked with triple star. Triple star means it is highly significant. So that means mental age can predict your IQ. This is the information from here. Look at anxiety. Anxiety is also highly significant. That means anxiety is also useful in predicting IQ. Look at depression score. It is also star. That means it can also predict IQ. You follow my point?
I follow, sir.
Now look at the next 3. Stress. What about the stress p-value? 0.18.
Yes, sir. More
More than
0.05.
0.05. That means, although initially you have thought that stress could be one of the component to predict IQ, but it is not. Same thing is with communication score. Same thing is with convolution score. Yes or no?
Yes, sir.
That means out of the 6 predictors, how many are important?
3, sir.
Only 3. Then why unnecessarily to include other variables? You follow my point?
I do, sir.
Why unnecessarily to include other variables into the model? We should not include them because they are making insignificant contribution to predict IQ. They should be thrown out of the model. Yes or no?
Absolutely.
Yeah. So in next time, you see, now you have the values here, R square, adjusted R square. Now, you see, this, there is one F value. This F value, and this is the F, there is one F value, which is P value. Look for the F value and P value. P value of F is significant because this is 6.395 into e raised to power minus 15. So it is highly significant. What does this mean? This simply says that out of the 6 predictors, if this would have been non-significant, so suppose this P value would have been non-significant, suppose this would have been only 0.395. Let's say this is 0.395. What does this mean? That this will simply specify that none of the predictors are important. None of the predictors are important if this F value would have been non-significant.
Including those who are significant above
No.
the table.
Let me just complete it. If this would have been non-significant, if this F value would have, actually, what is this F value testing? Let me tell you. If you are having a pen or pencil, you can note down, please. Beta 1 is the coefficient for mental age, beta 2 for anxiety, beta 6, beta 3, beta 4, beta 6 for this. Actually, it is testing this hypothesis. H0, beta 1 is equal to beta 2 is equal to beta 3 is equal to beta 4 is equal to beta 5 is equal to beta 6 is equal to 0. That is your H0. That means all the regression coefficients are 0. You follow my point?
I do, sir.
Now, what is alternative? Alternative is at least 2 of them are not, at least one of them is significant. At least one. There may be 2, there may be 3, there may be 4, there may be all of them. But alternative will be at least one. At least one. Even if at least one of the 6 is significant, your P value of F will come out to be significant. Now, in our case, out of the 6, 3 are coming out to be significant. That's why at least one has to. So in our case, 3 are coming. So that means that's why this P value is coming out to be significant. If there is no star here, you will immediately check that this P value will be non-significant. This means H0 will be accepted. What is H0? That means you cannot, H0 is beta 1, beta 2, right up to beta 6. All are 0. If all are 0, that means though there is no contribution of these independent variable to predict IQ. Yes or no?
Yes, sir.
So that is the idea of this F value. That is the idea of this F value. And it says that 3 of them are significant. Now in the next one, I have removed these 3, those who were non-significant. So I have removed the stress, communication score, convolution score. So I have to update my model. And how to update the model? This is the way. Model 2, update the previous model, model 2 minus. So how to put all the variables minus this variables. So if you put curl and dot, see, give the model, this is the command, model, comma, curl, full stop. Curl, comma, full stop means include all the variables first. Then minus. Minus which one? Stress, communication score, convolution score. So they have been excluded. You follow the command or not?
Yes, sir. We are excluding non.
सर इससे तो अच्छा है कि जो लेना है वो सेकंड टाइम रिजल्ट देखने के बाद जो लेना है वो ले ले.
Exactly. आपका ये भी कर सकते हैं कि IQ में मेंटल एज, एंजाइटी, डिप्रेशन को रखिए और इनको हटा दीजिए. वन एंड द सेम थिंग. या ही इज सेइंग एब्सोल्युटली राइट. या आप अपडेट कर दीजिए मॉडल. उसमें दिक्कत क्या आती है मैं बताऊं आपको. उसमें दिक्कत, देयर इज अ प्रॉब्लम बिकॉज समटाइम्स वी हैव टू डील विद 50 वेरिएबल्स and only 2 I have to remove. So I have to take 50. यहां से बीच बीच में मुझे ढूंढने पड़ेंगे कहां कहां पे हैं. But if I give this command, all of them, and I'll just remove that these 2 you should remove. You follow my point?
Yes.
That's why sometimes update is useful. Is that okay?
Sir.
Yeah. Okay. Then update the model, and it has been updated. And summary model, you can see all the 3 have been removed from the model. Only those have been retained which are making significant contribution to predict your Y. So what is your final model now? That IQ, is equal to, can you write down the equation from here? Minus 13.66725. This is your intercept plus 0.70162 into which one? Mental age plus other variable is 0.90582 multiply with which one? Yes, please.
Anxiety.
Plus the last one is 4.62379 multiply with depression score. Depression score. This is, so this is your final equation. This is your final equation.
One small question, if you don't mind, sir.
Yeah.
The star has increased for depression in the second model, sir. Is it because that we have removed some of the variables?
Yeah, because now its impact has also improved when you remove other variables. Its impact has improved.
I understand, yes.
Yeah, because it is taking a collective effort from all of them. So it has improved. Yeah, any other question? Yes, please.
Sir, multiple R star and adjusted R star.
Yeah. Now we are coming to a very important point. Now there are two terms here. One is R square. R square value is 0.9945. Adjusted R square is also. You can note down, please. There should not be much difference between R square and adjusted R square. There should not be much difference between R square and adjusted R square. Now, let's say your R square value is 0.9945, but adjusted R square is 0.6935. Then there is a big difference. Then there is a big difference between R square and adjusted R square. What does this mean? This simply means that there are some irrelevant variables into your model. Now, how do you explain adjusted R square? See, how many predictors initially we have? Anybody, please? How many predictors? Any independent variables we were having?
6, sir.
6. Now, if I include the 7th one also, let's say I include height, I also include weight, I include BMI. The more independent variables you include, value of R square will always increase. I'm telling you the difference between R square and adjusted R square. Listen to me carefully, please. The more independent variables you increase, the value of R square will go on increasing. But adjusted R square, listen to me carefully, adjusted R square will only increase when additional independent variables are making a significant contribution to predict IQ. If there is no significant contribution of additional variables, adjusted R square will remain the same. It will never increase, but R square will go on increasing. What does this mean? That means if there is a big difference between R square and adjusted R square, that means some irrelevant variables are there in your model. You follow my point?
Now,
will fall.
yes.
Now,
will fall.
let me explain you simple way. What is the difference between R square and adjusted R square? Let's say there is a heavy box. There is one heavy box, and 4 people are carrying that box. 2 on the front and 2 on the back. They are moving. Now, one of their friend has joined them. He says, let me also share some of the load. And he come into the center. Now, instead of 4, there are 5 people. There are 5 people. Obviously, this 5th one will also share some load. So your R square is increasing because he has shared a little bit. Maybe this heavy box, other people are sharing 50 kg, 60 kg. He may be sharing maybe 20 to 25 kg, something like that. Okay. Now, one more person has come. He says, let me also share something. And he also stand in between. So there are 2 on the front, 2 now in the middle, and 2 on the back. Now there are 6 people. Obviously, he may be carrying say 10-15 kg or something like that, which is making a so value of R square. He's sharing. Sharing means value of R square will further increase. The sharing is increasing, right? Now the 7th one has also come. He says there are already 6 people working. Even if I put my simple hand without any showing to it anybody, or put just a finger, even I can show that I am working. But he just put a finger. He just put a finger, and maybe 50 gram or 60 gram will be shared with that finger. Value of R square will increase because it has shared a little bit. It may increase in points, but adjusted R square will not increase because it is not making a significant contribution. You follow my point? So if there is a big difference between R square and adjusted R square, that means some irrelevant people are there who are just putting their fingers, but they have no contribution actually. This is what do you mean by this?
Sir, R square, can it go beyond hundreds?
It cannot be. It is always between 0 and 1.
Oh,
Always,
okay, sir.
not
0 and
100 even. Between 0 and 1.
I'm in 1 only, sir.
Yeah. So that is a multiple regression. All right. Yes, please.
Yes, sir.
I
Yes,
think
sir.
enough for today. Enough for today.
I think
Yes,
yes,
sir.
If you need anything else, any question, I'm trying to explain the crux of the problem, what we are doing actually, and how
Hello,
it is
sir.
happening. Yes, please.
सर आपने अभी कहा कि एडजस्टेड आर स्क्वायर कब मतलब बढ़ता मतलब
Adjusted
कब
R
इंक्रीज
square,
करेगा एडजस्टेड आर स्क्वायर
adjusted R square तब बढ़ेगा अगर जो आप एडिशनल वेरिएबल्स अगर अपने मॉडल में डाल रहे हैं उनकी कोई सिग्निफिकेंट कंट्रीब्यूशन होगी आईक्यू को प्रेडिक्ट करने के लिए. अगर वो सिग्निफिकेंट कंट्रीब्यूशन नहीं होगी, आर स्क्वायर तो बढ़ेगा ही बढ़ेगा क्योंकि शेयरिंग बढ़ेगी, बट एडजस्टेड आर स्क्वायर तभी बढ़ेगा if they are making a significant contribution to predict IQ. Otherwise, adjusted R square नहीं बढ़ेगा. It will remain as there.
ओके सर
Yeah, that's the difference between R square and adjusted R square. किसी बुक में आपको लिखा नहीं मिलेगा, इसीलिए मैंने आपको बॉक्स का एग्जांपल लेके समझाया कि अगर 6 लोग बॉक्स को संभाल रहे हैं और आप 10 और लोगों को बीच में लगा दें तो वो अननेसेसरली हर्डल ही क्रिएट करेंगे, उनकी कंट्रीब्यूशन कोई ज्यादा नहीं होने वाली है. यस और नो?
यस सर
क्योंकि वो एक दूसरे पे डिपेंडेंट होंगे, ये उठा रहा चल ठीक है यार, ठीक है चल रहा है काम, तो उनकी कंट्रीब्यूशन नहीं है कुछ की. ऑल राइट, सो दैट्स ऑल फॉर टुडे.
Sir, before we end, sir, one small question, sir. Sigma squared, sir, is it, can you just briefly tell me what is sigma squared is like R square? I mean,
What is
it,
sigma square? Sigma square in this today's talk or something else?
no, not in today's thing, sir. I have one result with me where sigma squared
See,
also has been. Yes.
Sigma square is a measure of variation. How much variability is present in your data. R square is a coefficient of determination. It's a multiple correlation. How one variable is related to all other variables. R square is totally a different aspect. R square will give you strength of relationship between Y and independent variables, all of them taken together. For example, relationship between IQ and mental age, anxiety and depression score is 99.45%. That means it's 0.9945. Very high correlation between IQ and these 3 variables. This is what it means by R square. Sigma square just simply give you what is the variation of this data. For example, I'll just show you. I compute variance. Let me compute the variance of X. Variance of X, and run this. So this is the variation of X, right? Hello. So this was the data. This is a variation of X. That means it's a very large variation is there in the data. Very large variation. It's better to compute. Generally, we compute standard deviation. So standard deviation of X, and run this. So this is the standard deviation of the data. So if you can consider another data set and you compare the two, if the variable which is having less standard deviation will be more consistent. This is what do you mean by standard deviation.
Okay, sir. Thank you.
Standard deviation is giving you the consistency of the data. Let's say I take a variable here. I'll give you one example. Let's say I take a variable here where all the values are 5, 5, 5, 5, 5. All the values are here. Now, what is the variation in the data? Yes, please.
No.
See, no variations.
No variation, right? So this is my data. I compute the variance of this. Variance of X. And look at this thing. 0. Because all the values are consistent. So variation measures the consistency of the data. Smaller the variance, greater is the consistency in the data. This is what we mean by variance. Is that okay?
Yes, sir.
Yeah. Any other question? I'm happy that you are asking question even at 7 o'clock.
Sir,
Yes, boliye, madam.
sir, actually, from the p-value of anxiety, we can explain it is significant. But please explain the value of p e minus something.
Okay, I followed your question. Whatever you are saying, you see, you are saying something like this.
Yes, sir. The value of p for
Okay.
the variable anxiety or anxiety.
Now
we
listen,
can
listen to me. Listen. I followed your question. Okay, do you have a pen? You have a pen
Yes,
or
sir.
pencil or not? You have a
Yes,
pen or
sir.
pencil with you? Write down,
Yes,
write
sir.
down, please. Write down. Just write down. For anxiety, you can write down 3.20. Just write down 3.20. Have you written?
Yes, sir.
Into means cross 10 raised to power minus 12. 10 raised to power minus 12. Have you written this?
Yes, sir.
So your value will be how much? 3.20 into 10 raised to power minus 12. If this would have been 10 raised to power minus 2, you would have divided by 100. Hello.
Yes, sir. Yes, sir.
And if you have 12, you would have divided by 100 followed by 10 more zeros. Is that okay?
Okay.
So p value will, where it will be 0.000000320. That is your p value. It is certainly less than 0.05.
Okay.
If it is certainly less than, so E stands for 10 raised to power actually here. So wherever e raised to power minus 11, e raised to power minus 12, that means this p value is very, very small. This
Okay,
is the
sir.
meaning.
Thank you, sir.